Thank you, Melba. Thank you all for coming in this bright and early. She made it sound like I'm so old. I started at 12, seriously. So I started my career, as you can tell. I've been in IT all my entire career. And actually, when I was going to college at USF, I used to come to Lakeland Utilities, the pink building with the lake. If any of you know that building, I used to come to that building for, I used to be part of the control systems division, interning there for 2 semesters. So this highway is pretty familiar. I used to go back and forth quite often. So I'm sure many of you, or most of you, know Verizon. You've probably known Verizon as a telephone company. And I just want to share with you that we are a lot more than a telephone company today, right? So I'll start with a little video to get things going.
At Verizon, we're all about creation and development for everything that's coming next. We're big into the Internet of Things, making places like farms, hospitals, cities, even oyster beds a lot more intelligent. We're also a major player in telematics, helping large fleets run better, major car brands get smarter, and making most any car home. When it comes to mobile video, we keep serving up more programmatic advertising, and lots more new content. And our engineers are creating the technology to power the next generation of digital. At Verizon, when it comes to building the future, we invite the world's brightest creators, developers, engineers, to test their limits, follow their passion, have some fun, and become part of something pretty darn big.
All right. So as you can tell by that video, we are a lot more than a telephone company. And even though we started off as a phone company, we have the largest wireless network in the United States. We have one of the largest all-fiber networks, the Fios deployments that we have across the nation. We also have the largest global IP network that is supporting many of the largest Fortune 100 companies across the globe. And in addition to that, so we have established ourselves in the network space. We are now undertaking and actually right in the middle of all the Internet of Things, digital media and communications, and totally an innovative company that we've been in the business for. And as you can tell, we are ranked number 13 in the Fortune 500 companies, and have global employees. We're a global company with employees across the Asia, EMEA, and the United States, over 160,000 employees globally, all right? So some of the major areas that we focus on from a technology perspective, and I think this is what you're going to relate to the most, is the Internet of Things. I'm sure many of you have heard that term before. It's the new, trendy term. I'll get to it in a little bit and provide you some more details about it. How many of you have heard machine-to-machine communications? So the Internet of Things is really the new buzzword. It's originally started as machine-to-machine, right? So when you're talking about the Internet of Things, what you really, simplistically, if you want to explain it, think about the DNA. You're talking about digital devices, that's the D, and the network, and A, application automation. So you're talking about connecting multiple devices globally through a vast network and through applications. So the application automation is what's allowing you to manage and manage those devices. So when you talk about the Internet of Things, some of the examples that you'll hear is connected homes. Your your alarm systems, your refrigerators, all of these have technology in them that you can remotely manage and connect, right? Your thermostat in the house that can be managed. Connected cars, you saw some of that in the video. You have examples of telematics, so you can put in those devices in your cars that allow you to manage, troubleshoot, call for assistance, all those kinds of things. So that's another example of connecting. You also have, most of you probably have Fitbits. So it's, again, self-help systems, right? You're talking about systems that are used to provide you a better life in general. So that's what the Internet of Things is all about. And daily, on average, about 5.5 million devices are being connected through the Internet of Things. And the expectation is that by 2020, you're going to have about 20 billion devices connected globally through the Internet of Things. So that's the business to be in. That's the technology to be in. That's where all the innovation is taking place, right? So that's, you'll see a lot of those examples every day in your day-to-day lives, and it's become to the point where you can't even manage without your smartphone, right? When the Samsung 7 Note started exploding, people were having a panic attack because, those battery problems that they had recently with the Samsung phones. You figure out that you're so dependent on these devices for your day-to-day lives. Some of the other areas that we've gotten into with the recent acquisitions, we've been acquiring several companies that are going to help us get into the Internet of Things space and in the technology space. So one of them recently was AOL that we just acquired a couple of years ago. Again, for digital media and advertising is where we are focusing on that. The other one we are about to acquire is Yahoo, coming up next year. So, and many other companies, Uplink, that allows you to do a lot of digital media. For IPTV, OnQ was another company we acquired. So the idea is everything is going to become over the top through the strong wireless network that we already have. We want to leverage that above and beyond what you can do with just telephones and the internet, right? So that's the focus that we're going to have. And the underlying foundation for all that is our network, obviously. So you need to have a very strong network that you can deploy all these great applications to. So again, innovation is where it all is, and technology is where it all is, if you look around the globe today. So I wanted to start with, what is cloud computing? To do all the Internet of Things stuff that I just talked about, you need a robust infrastructure. That's where cloud computing comes into play. So the National Institute of Standards and Technologies came up with the definition, the basic definition for cloud computing. What it really is there are 5 tenets to it, right? One is on-demand self-service. What you're talking about is you have the ability to consume resources like compute, storage, network, those kinds of resources on demand when you need it. It can be sitting somewhere up in the cloud. That's a general idea, that you can consume it whenever you need it. So that's a requirement to be a cloud. Resource pooling. This is something that's been happening for many years already, the concept of virtualization, to be able to pool resources rather than the physical standalone servers that you have sitting in different locations. All of our labs these days, all of our data centers these days, all are virtualized where you're sharing resources with other people rather than having dedicated resources that you're relying on and paying for. So pooling is critical, and it gives you the impression as the end user that you have unlimited resources that you can consume at any time. And then you talk about the broad network access. What that means is from anywhere, from your smartphone, from India, from anywhere on the globe, through any device, you're able to access these resources anytime you want. So that is a critical element to call it a cloud. And then the next item, which is really important, is rapid elasticity. What we're talking there is the ability to spin up and spin down resources when you need them, rather than having to wait for somebody to go purchase a new computer, set it up in the lab, and configure it for you to use it. So again, this gives you the impression that you have unlimited resources that you can spin up when you need more. And the perfect example for that is when you have new applications that you're deploying, web applications that you're deploying, suddenly it's a huge hit. And a lot of consumers are hitting that web app, right? So you need to have the ability to spin up your app web servers very quickly so that the user is not impacted with performance or capacity. So that's what provides you the elasticity. And last but not least is full transparency around cost, right? So you're talking about measured services. What that really means is the ability to meter or pay for your services. It's very similar to what you would see in a utility company. When you, electric or water, you're charged for what you consume. So there again, you have this unlimited resources, mostly, except for when there are hurricanes and there are systems that are overloaded. But similar concept if you think about it. You have the utility company, similar to that. You have the cloud, you have unlimited resources that you can consume. You're going to get charged for it. So the accountability now falls on you, the end user, to make sure you're consuming those resources effectively. So that's the basic concept around cloud computing. Everyone with me so far? So there are three major types of services. Cloud is all about service-oriented architecture. So the three major services we're talking about are infrastructure as a service, IaaS, you probably have heard about it. Platform as a service, that's a layer that sits on top of it, which is a PaaS. And the third layer is software as a service, which is SaaS. So let's start with infrastructure as a service. That's where you're really getting your compute, storage, your network, those basic elements that are required for you to develop something on, right? So your laptop comes with compute, storage, and network connectivity. So this is taking it to the broader spectrum. And then the layer above that, that's called the PaaS layer, is allowing you to abstract the underlying infrastructure and just give you an application that you can develop on. So a lot of the PaaS applications like Pivotal has a Cloud Foundry PaaS, Red Hat has OpenShift PaaS. These are all frameworks that allow you to develop your application without having to deal with what's provided in the underlying infrastructure. And the third layer on top of it, which is called the Sas layer, is if you don't want to deal with the infrastructure or a PaaS to develop your app on, examples like Salesforce.com. What else? ServiceNow, a lot of these applications that allow you, it's a whole application suite that's running in the cloud. All you're doing is consuming that application as an end user through a web portal, and you're getting charged for that consumption. So these are the three major models. And what we have responsibility in Verizon is to, in the IT department that I have responsibility for, is to provide that underlying infrastructure layer and the PaaS layer, because our end user is all the IT developers. We have in Verizon about 10,000 IT developers globally. So they are all doing development work for IT. So the examples are VerizonWireless.com. When you go there to order a new phone or pay your bills, there's a lot of call center applications. So when you're calling the call center for help, they have to use these applications to help troubleshoot and manage your bills and so on and so forth. So all those applications are developed in-house, and those developers use these frameworks across the different data centers to be able to consume those resources. All right, and there are several different cloud models. The three major models that are out there, the private cloud, the public cloud, and the hybrid cloud. So the private cloud model is what I was just talking about, which is you are on-premise in your environment, managing it for your consumption locally. You could also have it on-prem. You could also house it as a colo location in a different data center, but it's primarily for you to consume as your company resources. The public cloud, you all have heard about Amazon Web Services. That's the most popular public cloud out there, AWS. There's the Google Cloud Services, which is gaining a lot of popularity. And then there's the Microsoft Azure, which is another cloud that is very Microsoft-oriented, that is also gaining a lot of popularity. But AWS is the one that's been in business for 8 to 10 years, and they're doing phenomenally well. And what they provide is you don't have to worry about infrastructure, you don't have to worry about a data center. If you're a small business and you just want to start by consuming resources and compute resources, you want to run an application, you want to set up a quick web app that you want your end users to consume, they allow you to do that, and all you're doing is you're getting charged on a monthly basis by the hours of minutes of time you spend in that cloud. So that's the public cloud. And the hybrid cloud model generally is a combination of both. And what that allows you to do is, in our scenario, Verizon has several data centers. We had 14 data centers, we have consolidated down to 7. Managing a data center is very expensive, right? So when you have these data centers and you are running out of capacity in the data centers, if you're trying to set up additional infrastructure and capacity, it takes a long time. So what you try to do is burst into that public cloud. So if you're set up in a hybrid cloud model, when you have a scenario like a hurricane setup is a classic example where you have an overload of capacity demand, you can burst out into the public cloud and run that same application there rather than having to set up all this stranded capacity in your data center floor, which is very costly. So that's a hybrid cloud model. And many companies are also, especially enterprises, are also looking at a multi-cloud model. So it's not just hybrid for bursting. You want to take advantage of different clouds for their specialty, right? So AWS is a very general purpose cloud that gives you some, 650 some service offerings that you can consume. Google Cloud is very oriented towards big data analytics, and they have a lot of capabilities there. Microsoft allows you to seamlessly migrate a lot of the Microsoft applications into their space. So a lot of applications have different specialties. A lot of clouds are different specialties, so you could also have a multi-cloud environment, which is something that we are looking at in addition to our on-premise cloud. All right, so what are some of the benefits of cloud? Just talking through some of these scenarios, you can see that, first is better use of your resources. Again, the accountability is on you, the end user, to make sure you are really managing your resources efficiently because you're getting billed for it, right? And the billing model, people get accountable when you have to pay out, all right? So the billing model is very critical, and it's a shift in the model. Previously, it used to be a CapEx or a capital-oriented model. So in a data center, if you have to set up all this infrastructure, you have to spend capital for it, right, to set it up. But when you go into a cloud, you're going really into an operational expense model where you're getting a monthly bill that you have to pay for. So that the benefit is, if you're a small company and you don't have a lot of infrastructure capital to invest, you can just pay on a monthly basis. I mean, you say you don't need it and your business is done, or you want to shrink it down, you have the ability to do that by reducing your consumption on a monthly basis. The flexibility that it gives you, again, the ability to go to different clouds and consume their resources based on your requirements makes it very flexible rather than setting up your own data center, right? And what that allows you to do is, in such a competitive world that we live in today, every new feature, every new app that comes out, if you don't beat your competition, you've lost the game, right? So the agility for developers to quickly stand up an environment and quickly deploy their applications rather than actually focusing on the underlying infrastructure, that's the business agility that is very critical in a cloud environment. And certainly with all this comes efficiency. You're managing your costs, you're managing your user experience, you're managing your efficiency of how you manage your business overall. Right, so let me talk a little bit about Verizon's cloud journey. We started, as any other company, many, many moons ago, actually 8 to 10 years ago. We were a very physical infrastructure-oriented company. So all the data centers have these monster hardware. I don't know if you guys have been to data centers. Verizon has an awesome one in the Tampa Tech Center, if you guys ever want to tour it. But the monster storage arrays, monster computers, and all the network to connect it used to be very physical, and setting up and managing physical infrastructure is very costly. And it used to be dedicated to individual applications for their purpose only, purpose-built infrastructure. That was the traditional model. Certainly that's not a sustainable model, and you can't continue to expand and grow your data center. So from that, we started switching, the industry as a whole started switching into the next piece, which is the virtual infrastructure model. How many of you have heard about Vmware? All right, so Vmware was one of the pioneers in virtualization. And what that allowed people to do is share resources, right? You have the underlying hardware infrastructure that's physical. You put a layer of software on top of it called the hypervisor layer that allows you to virtualize your entire environment, and you can share those resources across multiple resources, right? So that allows you to more efficiently consume your resources. And what that also allows you to do is do some automation, because you're able to automate that hypervisor layer rather than physically interact with the infrastructure, right? And then from there, we have transformed into the private cloud environment. So for the past 4 years, I've been driving our private cloud journey. What that is doing is taking it one step further above and beyond the virtualization layer. And what we're really doing is talking about API-driven automation. Application interfaces, programming interfaces. You guys, I'm sure, know about APIs, right? So the idea there is you are communicating with the underlying infrastructure through APIs. It's all software defined. And that's the future state the world is going to. Networks, for example, which were very hardware centric, are switching to software-defined networks. You'll hear the term SDN used a lot because that's the new way of doing business. What that's allowing you to do is programmatically manage your devices, programmatically manage your infrastructure through APIs. And as we talked about all the cloud platform, that's what's allowing you to do that. And along with that, what's happened is a lot of the traditional software that used to be run in a lot of these environments, companies were collecting a whole lot of software licensing money. IBM WebSphere, WebLogic, Microsoft's products, SQL Server, and all these software technologies that are out there, there's significant competition now with open source technology. And it allows the consumer doesn't have a lot of investment capital to still get and take advantage of a lot of these software components. For example, instead of SQL Server or Oracle, you have a lot of open source databases, right? You have MongoDB, Cassandra, MySQL. What that allows you to do is you can deploy your applications by downloading software from these open source providers and manage your environment. So this has allowed, again, automating our entire infrastructure, automating our framework, automating our applications a lot more easily than we were able to do many years ago. And just to give you an idea of how we have established our cloud, this is our private cloud framework that we had designed a few years ago, and it's still evolving every day, literally. What you can see is, every user wants to consume resources. How many of you have gone to AWS to get capacity to do any programming? It's so easy. A credit card and you get resources, right? So I would definitely encourage you to do a simple hello world application in AWS to get a sense of what that means, to go set up an environment and deploy an application. So what that allows you to do is, you have a simple user interface. So the developers, the interface is dummied down so the developers don't need to understand the underlying hardware, how the physical connectivity works, any of that stuff, right? So instead, they can focus on a simple user interface, standard offerings. That's key, because you need to make sure you have standard offerings and capabilities that are provided to the user. So I can get a 2x4, 2 CPU, 4 gig memory virtual instance. I can get a certain PaaS software layer deployed on top of it, and then I can start deploying my application on top of it. So that user interface allows us to do that. We built that user interface in-house to be able to flexibly manage our developers' resources. The other mechanism where users are coming to consume resources, again, is through full automation, continuous integration, and continuous delivery. That's the CI/CD model we were talking about. What this is allowing you to do is programmatically, when it's a machine-to-machine talking, there's really no user involved, right? You have to have the ability to automatically deploy your applications through scripting and automation end-to-end, without having to go to a portal to get resources, without having to talk to a human being. So the goal behind this is enhancing the developer experience by the end-to-end flow being fully automated. So it's not like developers hate infrastructure people or anything, but it allows them the flexibility of managing their environments a lot better, right? And then you have this whole layer called the orchestration layer. What that allows you to do is orchestrate and automate all these requests that are coming in from different users, right? Is it coming through CI/CD? Is it coming through the portal? I'm making intelligent decisions in that orchestration layer, and based on the requirements that are being submitted, choosing the appropriate cloud that I want to go to. So we have the VMware cloud that we can consume for non-prod and production. Then we have the OpenStack cloud. OpenStack is, again, the open source platform that is a huge competition for the VMware type environments, right? And then last but not least, having the same ability to consume resources in the public cloud. So the end user really doesn't need to choose, okay, give me this kind of hardware with this type of configuration. They just need to say, here's the specifications of my user requirement. You do all the intelligence behind the scenes through automation, right? So as you can see, everything becomes service-oriented. You're saying, I want so much compute. I want so much storage. I want to connect through DNS. I want an IP assigned. I want, security is huge, so you have to make sure only authenticated and authorized people are allowed to access it. So I want to automate the security profile. So you can see that all of these become services that the user can consume through the automation layer. So this is just an example of what we have implemented, and most cloud providers in the public cloud use the similar model to deploy their environments. But as you can see, the most critical aspect of this is it's technology, it's automation, it's IT, right? So without IT, to be honest, the world can't exist anymore, right? So what does the future look like to you if you look at this? It's basically a digital world, right? And software-defined everything is the way to go. And regardless if you're in the, I know there are a bunch of biology students here, regardless of what field you are in, an English major, anybody is dealing with IT every single day, right? So and the technology is what's going to drive the future. So there is a huge career opportunity in that field. You don't have to necessarily be just an infrastructure geek sitting there hacking away at computers. You have several opportunities spreading all across these different entities to consume IT. So as far as a career in IT, I've been with Verizon, oh dear Lord, a long time. But like I said, I started at 12. But we do provide a lot of internship opportunities as well as new college hire opportunities at Verizon. We have been recruiting at USF and UF. I've been going to campus recruiting for many years now. We do come to UCF a few times as well. I know there's definitely interest here to get engaged in that kind of a program. We offer summer internships, which is 10 to 12 weeks of internships with repeat internship students come in as sophomores, juniors, and then there's, once you graduate, the opportunity to come in as a new college hire. We also have a leadership development program, which is a very interesting program for new college hires. It's a 3-year rotational program that you go through different parts of IT. So for example, I have several college students who have rotated through, they come into the cloud framework, then they go into the development side, the DevOps side, where they're talking about all the CI/CD automation and so forth, rotate into the security side. Security is huge. You see news all the time about different companies getting hacked, right? When we don't want to be in that kind of news. So security is a huge aspect of our day-to-day lives. So definitely a lot of opportunity in technology and IT, and I would encourage all of you to stay focused, be engaged, and take advantage of every opportunity you get. All right? Thank you.